metal finishing, and porcelain building finishing. The TP&P system, now on videotape, is a series of logical steps implementing unique techniques coupled with mechanized and artistic methods. The 6 video modules start with models and dies and proceed through porcelain building finishing and glazing and staining. Taught through seminars around the world the past 7 years, the TP&P system has been a proven profit and productivity builder for dental laboratories, ranging from 1 technician in size to 150 technicians. Each module is broken up into 3 sections: a preview, a main body, and a summary. Talladium's profit and productivity system on video consists of 6 modules. Module 1, model and dies. 2, wax up. 3, investing, casting, metal finishing, pre- and post-soldering. 4, metal conditioning and opaquing. 5, porcelain building. 6, porcelain finishing, staining, glazing, corrections, and polishing. Model and dies, module number 1. The proceeding section is a preview of the model and dies module. The model and die phase represents the second duplication step in a chain of 5 duplicating steps. But this is the first for the dental laboratory. The proper preparation of the dies and model represents the foundation of all the subsequent steps in the porcelain fused to metal process. A faulty technique or sloppy handling in the model and die phase will cause a costly remake and/or laboratory time and labor lost. Moreover, the proper model and die preparation facilitates the waxing technique. A paramount factor in the successful preparation of model and dies is the correct usage of die stone, a pinning system, die sealer, cement spacer, and a blockout material, along with a proper burr for accurate die trimming. Wax Up, Module 2. The proceeding section is a preview of Wax Up. This Wax Up system is predicated on the use of Talladium's non-precious alloys. Talladium's non-precious alloys have unique physical properties that, 1, produce better bond and compressive strengths. 2, matched coefficients with various porcelain systems, and 3, a matched heat conductivity between the heating and cooling cycles of the porcelain and the metal. The benefits of this wax-up system are the following. 1, it reduces metal finishing to 0. 2, it produces coping and margin accuracy. 3, it optimizes the porcelain shade accuracy and translucency. It is important to note, most porcelain companies produce a porcelain that at 1.5 millimeters thickness will produce an optimum shade and translucency. And the 4th benefit is hygienic. The thin connectors produce more open embrasures to promote better dental hygiene. Investing, casting, metal finishing, pre- and post-soldering, Module 3. This section is a preview of investing and casting. Aside from Talladium, many of the general principles in these techniques covered in this module can be applied when using other ceramic alloys. To review, in the waxing module, the dip pot waxing technique enabled the technician to wax patterns evenly at 0.2 of a millimeter. With a proper investing and burnout procedure, utilizing Talladium's microfine investment, porosity, and bubbles are eliminated and satin-smooth castings are produced. This reduces metal finishing virtually to 0. The unique physical properties of Talladium's alloys exhibit a fluidity in the casting process that ensures perfect castings of 0.2 of a millimeter thickness time after time. Thus, the metal finishing department's only responsibility will be to reshape pontics and lingual collars. This section will preview pre-soldering. This pre-solder was developed from metallurgical data developed in the aerospace industry. The criteria for this solder was 1, it had to withstand high ceramic fusing temperatures. 2, produce a wetting action on the parent metal. 3, have a matched coefficient to dental porcelains. And 4, produce an oxide for optimum dental porcelain to metal bond. And finally, 5, be trouble-free in the soldering process. This section will preview to be post-soldered. Talladium's post-solder can be utilized when soldering non-precious to non-precious, non-precious to ceramic golds, and non-precious to crown and bridge golds. The post-solder technique is relatively simple. The post-solder flows without vacuum in a porcelain muffle at a temperature 400 degrees Fahrenheit and opaquing. Module 4. This section is a preview of metal conditioning and opaquing. A key step in the porcelain fused to metal process is producing the proper oxide to maximize the porcelain fused to metal bond. Another section of this tape covers quick opaquing. This technique has 2 benefits. Number 1, quality. It enables the technician to opaque to achieve maximum coverage and block out while maintaining an even layer of less than 1/10 of a millimeter thickness. The second major benefit is speed and production. The technique enables a technician to achieve a production of at least 30 units per hour. Study this module closely. With a little practice, one can duplicate this same production rate while maintaining a high level of quality. 5 surface domain range build-up system, Module 5. Module number 5 covers the system of building and carving porcelain. This unique system is predicated on the proper usage of a Talladium porcelain instrument and pre-condensing porcelain. The objective of this system is to systematically carve anatomy based on 5 surface alignments. Number 1, occlusal, 2, buccal, 3, lingual, 4, mesial, and 5, distal. Thus, an original geometric block of porcelain initially applied during the build-up is progressively and logically reduced to an anatomical form of the tooth or teeth in the arch. The benefits of this system are threefold. 1, it is labor-saving due to the fact the porcelain technician eliminates wasted motion by following a series of sequential steps in building and carving. 2, it produces a case in a state of completion that is conducive to easy porcelain finishing. 3, this system of porcelain buildup is duplicated in the porcelain finishing phase. As a result, it is a logical system of simplicity that can be easily learned. Moreover, it produces better coordination between the porcelain builder and the porcelain finisher. This build-up system of properly condensed porcelain ultimately produces a desired consistent shade tab glaze. Finishing, staining, glazing, corrections, and polishing. Module 6. This section is a preview. The objective in porcelain finishing is to align the 5 surfaces in relationship to the arch. The grinding procedures approximate the same system as porcelain building. That is, porcelain finishing is a plan of progressive logical steps, starting with mechanized functional grinding and leading to detailing anatomy through artistic grinding. In this system, The 5 surfaces, occlusal, buccal, lingual, mesial, and distal, are systematically ground down from a relatively flat surface to contoured surfaces and brought into alignment. The benefits of this technique of porcelain finishing are twofold. 1, the technique saves time by eliminating wasted motion and repetitive steps. And 2, it enables the porcelain technician to achieve with more ease better aesthetics, function, and consistency. The success of this system is dependent on the technician's familiarization of proper cutting instruments and mechanized equipment. The selection of cutting instruments used in Module 6 was determined through years of experience with most of the cutting instruments on the market. The objective was to narrow down the numbers of finishing stones and discs to a minimum. The criteria for selection was as follows: 1, hardness; 2, durability; 3, grit; 4, a non-contaminating binder; 5, a true center; and finally, 6, cost effectiveness. Each of the cutting instruments was expressly selected to do a specific task in the porcelain finishing technique. The cutting instruments are only as good as the equipment driving them. To do a proper job of finishing porcelain, 2 types of handpieces are required. First, a handpiece with a consistent delivery of power and RPMs. In other words, a handpiece capable of going as slow as 50 RPM with a smooth delivery of power, and at the other end of the scale, a smooth delivery of power at 45,000 RPMs. This handpiece is used for gross reduction, contouring porcelain, and smoothing out thin areas. Second, a high-speed air turbine capable of achieving 450,000 to 500,000 RPMs. One that runs true and with adequate power. Use this handpiece for detailing secondary anatomy. With the proper cutting instrument, the high-speed handpiece cuts porcelain to a sharp detail with a minimum of effort. View Module number 6 closely. Follow each step and familiarize yourself with the proper applications of cutting instruments and the techniques. You are now prepared to produce better units in better time.